Hi everyone, my name is Marco. I'm from 3D Survey team, and today I have a pretty interesting webinar for you with the topic how to use drone and phone camera images in one project. And if we go to webinar topic for today, we have a nice project. It's this kind of small vineyard house. For this project, they need actually a building footprint. They need roof dimensions, that they know how much material they will need to renew it, and of course some specific points like the lowest and highest points. Then the second thing I would like to explain you, it's equipment which was being used here. In a third point, we will see detailed instructions for data acquisition, how to get the best results out of it, and what's specific of this webinar. So instead using just the drone images, we will use also hand shots in addition and try to get the best possible model out of it. Last point, the basic workflow with results and so on. We will try to represent you most out of it. What's the main goal of this webinar? I would really like to show you how the most successfully combine phone images together with drone images, because sometimes it's pretty tricky because the camera it's different, so phone camera is different that drone camera, and you need to be really careful to get really the same perspective at the beginnings, that those two cameras can combine together and that all images are at the end successfully matched. And first one is a bit detailed description about the project. So this was kind of a small object, 9 per 5 meters, nothing special. I could measure this with a total station and so on, but instead of using this, I had the drone in my equipment. I need approximately 50 minutes to do the mapping, and I need to measure one ground control points for orientation. Later you will see this was a Phantom 4 RTK which was used here. And what was my requirements for this project? The main goal was to deliver the building footprint. So I need to vectorize at the end the building corners out of it. I need to deliver roof dimensions of this building, because they need to know how many materials they need to order it and replace it. And this is everything in 3D. So if you're using a standard method like measuring tape or something like that, it's kind of more difficult and not so convenient. That's why this is a great technology. And at the end, I also need to deliver them some characteristic points like lowest point, highest points, and so on. Then I use a mapping approach, which is not the standard one. Usually customers are flying simple grid and that's it. But in my case, I'd like to get as much detailed object as possible. So the best 3D model from images to get out all the information. That's why I did a manual flight on 40 meters with the nadir camera. So the gimbal was turned 90 degrees down. And when I finish with this automatic flight, I add a circle mission flights, which I need to fly actually manually, because in the DJI Airtica app, there is no option to fly circles. But I'm a kind of a trained pilot, and this was super easy for me. What's important here, you will see also later in the software, I did more circles, and if I start with the grid mission on 40 meters, I start my first circle on 35 meters, then I go 5 meter lowers on 30 meters, 25, 20, and so on. So I try to connect all the images together to get the greatest model out of it. And at the end, I was flying actually at 5 meters above the terrain, or even less, because my phone images were triggered from 1.5 or 2 meter height, and I'd like to connect those two data sets together. Because I had an RTK drone, I used just single ground control points, which helps me to improve the height of the model. Probably without GCP points, I would get, let's say, also in a centimeter too. Sometimes there's a displacement of 10 centimeters, but to eliminate this error, I just use single ground control points and everything was fine. Usually, if we have bigger terrain, we use 3 to 4 ground control points, just to be on a safe side. This is surveyor approach. You always do some tests and so on. We need to deliver the building footprint of the basement, and from the first floor there were some corners which were under some kind of object, so that's why I decided to include also images from handshots triggered with phone camera, and let's see what kind of results we get out. Equipment which was used here was my phone, Google Pixel 5. It has actually, I think, 12 megapixel camera or something like that, and Phantom 4 RTK. Instead of using my phone camera, even better option would be to use a standard digital camera, because it has a bigger sensor, the pixels are bigger on the sensor, and of course the end result is much better than. But if you don't have a hand camera, take your phone and that's it. What's good to know it, turn off the GPS before you start triggering handshots with camera, because this telemetry is not so good that the drone telemetry, and at the end it will destroy actually the accuracy, or not so many images will be matched in the bundle adjustment. So turn off the GPS, that you're not going to geotag images which were triggered with phone. Okay, I use the Leica GNSS device to measure single ground control points, and of course 3D survey software for processing. Instructions for data acquisition, really quickly. I already explained in a short how it goes. So the first, I did a drone mapping grid mission on 40 meters, then circles around the objects. I did altogether, I think, 4 circles. So in a way, 30 meters, 20 meters, 10 meters, 5 meters. What's important here, get your drone images pretty to similar perspectives than the phone images. I know that sometimes this is not able to do it because you have some trees or something like that, but you will find maybe one corner where you can connect 5 cameras from drone with 5 cameras from phone or digital camera, which are kind of close enough that the informations are pretty the same, that they are the same distance from the object, and this is definitely the safest way. Then later on you can continue with your phone and go even inside of the objects. I forgot to do this one, would be even more interesting, but maybe on some next webinar. Then phone images start from the similar perspective. In most cases, if user write us that they are not satisfied with the bundle adjustment step, that phone images were not included in the object of drone images, this is the reason. So they changed the scale between those 2 cameras too much. They didn't have the same perspective and so on. And keep in mind also, when you are triggering images with phone, you need to have good overlap between images. So every detail needs to be on at least 4 or 5 images. So minimum overlap is 70%. And if you go closer to some objects, go step by step. So if you are 10 meters away from the object, from the building, don't go then directly to 1 meter, go from 10 meters to 5 meters to 3 meters to 1 meter. So something like that. Okay, we are back from the field, and I just copy all the data from drone SD card and get 2 folders. The first one is survey folder and the second one is 100 media folder. I also create a phone folder and copy inside my images from my phone, because I already mentioned here, we've been mapping here with the Phantom 4 RTK. The first thing was a standard grid mission, and images in a standard grid mission are usually written in a survey folder. If I open this folder and subfolder, we see those images from the air. So approximately, let's see, in my case we have 86 images from 40-meter flying height. If we move between the images, you can see those are perpendicularly turned down images, so 90 degrees camera gimbal. Here is our object of area. The second folder from drone is 100 media. Here inside we have all images which were triggered manually. So I clicked trigger camera for every image. Those were actually kind of a circle flight around my object of interest. which is the building in the middle of image. And I'm just moving between the images that you have a good feeling how I trigger those images. What is super important if you like to successfully combine all images in your end model. Better have more images than less images. Nevertheless, you can always exclude images from your model if the model is too detailed and so on. But if there are some images missing, maybe not all cameras will be bundle adjusted in your model. That's why this part of object was the most tricky one, because I also like to get the corner from the building here and also in the first floor, and sometimes it's hard visible, especially the upper corner here, because I need to create for this project footprint of the building. I need to deliver roof areas and lowest and highest point for the building, as I already mentioned. This is still flying with the drone. As you can see, I go really low to get all the details, also trying to get the detail under the roof and so on. I already mentioned again, it's great to have pretty similar perspectives from the drone and with the phone images. And I finish here. The closest one image, which will be pretty similar to phone image, is probably this one, and this one. And let's close now the manual trigger images and go to phone folder and see. You can see, so when I trigger this image with phone, it's almost pretty the same as drone image. And this is kind of a good starting point. And then when these first 5 images are matched with the model of drone images, I can go and continue walking around the building, go even closer. I under the roof to get also a lot of details, go around the building. Next step is I will create a new folder and name it like all images, and I will copy all images which were triggered manually in this folder. Okay, then all images with my phone, copy. Okay, done. And of course the images which were triggered automatic with the help of a grid mission, also paste them here. Okay, this is now my folder, all images, all together 331 images, and I will just copy me the link from the folder, and now we can start with the processing in 3D Survey. I will run the 3D Survey software, start with a new project, and this is kind of a standard workflow. I browse for my images, just Ctrl A, open all the images. The telemetry importer window pops up. I will select here EXIF data, and I need to select my coordinate system. It's in Slovenia. I also have my local GeoID, which is Slovenia Copper 2016, and import all the images inside. Data was successfully imported. The RTK will have high precision for all the images here, really nicely. 3 pixel images have also coordinates. The accuracy is, as we can see, 10, 10, 100, which is good enough. And in this way, we will try to match all the phone images with a complete model. It will take a bit longer, but nevertheless, there's a much better chance to include also those images in the model. So once again, before you start triggering phone images on a field, turn off the GPS of your phone, that all the imported images will be also then successfully matched. Okay, cool. Let's go to image again really quickly. If I'm moving down, and those are my images from drone. Still nadir images. Here we can see different name. Those are images which were manually triggered. And here we have another camera, Google Pixel 5. Let's see. And those are my images from the phone. Okay. If we see the telemetry view, here we can see actually images from the drone. This one is probably from my Pixel. If I close the two, we can see here in the list of the image names that we have two cameras here. So the DJI camera and Google Pixel 5. More or less everything is ready, nothing else to do than bundle adjustment. And my suggestion here is when you combine different cameras, always use hybrid model, which is kind of a global incremental together and probably will deliver you the best end results of a bundle adjustment step. So select bundle adjustment and click OK. Here we can already see the result of bundle adjustment. Totally 331 images, selected all of images and successfully registered 370 images. We can see the complete model here also. A lot of cameras, a lot of blue triangles because we are so close, the triangle is a bit bigger. But nevertheless, we see we successfully somehow combine drone images with phone images really nicely. What I'm super happy around is that we manage to overcome this step. When I go actually here up, not yet, a bit further. So up here, I go actually inside in the first floor, and all those images are actually successfully matched. Next thing is we need to orientate additionally this model because we have an RTK drone. Also phone images are super accurately orientated also based on RTK data, but we always suggest you at least to use, even if you have an RTK drone, at least one or better 3 ground control points to do the orientation just for the height control. So I have one GCP point in my case. Let me just browse to the GCP file. The file should be somewhere here, GCP. It's point number 6. It's non-projection because it's a RTK drone, so all the coordinate system are fine. Let's go to next step. This is not a 3D survey target. I just measure one detail points, and I should see immediately the green circle of almost right position. It was actually this corner of 2 bricks, which I mark it on the field. I will just improve now this position by using the leftmost on number 6. I could also select it here from the list, and I will accurately show the software. So this is here, and let's do maybe on a second image the same way. So number 6 is here, and when I go to next step, everything should be already fine. That's all good. I need to deselect those images where the GCP is not visible, and when I go to next step, I should get the accuracy. It will be super accurate because we have RTK images with a 1 or 2 centimeter accuracy. We have 1 GCP points, which will help us to improve the height of the model, that everything will be super accurately. We also have a GeoIT model in this case, and then based on all this data, also phone images with no telemetry will be combined addition, and the whole complete model will be accurately orientated. And the result is here. so super accurate because it's just a single point. This is fully logical. We just need to click on finish, and here we can see now orientated model also based on this one GCP point. This is so-called sparse point cloud. Even on a sparse point cloud, we can see where's our object of interest and so on. Okay, we are ready for third step. This one is a so-called reconstruction. I will do the reconstruction on a high level. This is, I think this will be more than enough, more than detailed enough. I will use my NVIDIA graphic cards to get really detailed model. If you have options to use NVIDIA, definitely do that because the model is much nicer, much more accurate and detailed. Okay, if I click OK now, I will start with the processing. This will probably take 2 to 3 hours for those 300 images. Then we'll see the result of reconstruction step. And here we can already see our result of dense reconstruction. It's a point cloud. We have in total 52 million of points. You see pretty big area thanks to the standard grid mission and super detailed model for our object of interest. If I turn on off cameras and zoom in additionally, you can see almost every detail is easily visible. And we also have a complete and perfect footprint of the building, this based on which we can easily use the CAD tools and connect actually our 3D polyline, which defines the footprint of the building. The second important thing we need here, we need to draw out the roof dimensions. Instead of using measuring tape or traditional approach techniques, we can now easily do this also in a CAD tab. And of course, then the lowest and highest point, it's easy to create it. But before we do that, we will just quickly select our area of interest, just like so. Couple of seconds to get the selected points in selection. And instead of delete selected, we will use delete other function, and we are going also to create a textured full 3D mesh for this smaller part. I'll click on mesh, calculate new full 3D mesh, point cloud, it's already selected the right one, we have just a single one. We would like to have texture, calculation level high, 2 million of triangles, and texture resolution full. So I would just leave it default settings and click on calculate, and then in a couple of minutes, or let's say in 1 hour, we have the also full 3D textured mesh. Okay, and the mesh is already here. Just wait a couple of seconds to get the texture on it. Okay, this is it. And this is our 3D model of a vineyard house, which will be renewed. And if we go to see what kind of detail we achieve, we can see that everything is really nicely visible. What was my goal in this project? To add also cameras from phone, is to get also really nice detail here under the roof, and then of course also here inside to get this detail out of it that I can easily draw later on with the CAD tool tabs and CAD functions and create the footprint I actually needed. Let's try and draw now my main important things for this building. So I need a footprint. Let's go to the CAD tab. What I can do here, currently I see point cloud and mesh, which are available for this model right now. So because I'm comfortable with the mesh right now, I will just select my mesh and I'm going to draw based on mesh because it's super detailed. Let's go back to CAD tab. I will first create a new layer, hosts, make the layer active, set my red color, thickness to 3. Okay, use the draw line tool, and I'm going to snap actually on triangles and on endpoints. Okay, so first let's create a footprint, so like so. I think it goes like that way. Let's see. Okay, it ends like so. Let's go here to the corner of the building. So this is kind of basement. We are drawing actually on a based on a fully realistic model. Thanks to the side images, thanks to the phone images, the complete model it's covered super nicely and super accurately. Sorry. Okay, I'm going to get this corner of the building. Yes, let's take this one, and then I will click and I will snap to my endpoint. Okay, this is my footprint of the basement. I could connect also the first floor, but I think I give you a good idea. Now I'm going to create some 3D points. Actually, I need 2 of them because of the height. Display, okay, name and height. The first one will be here in front of the building. Oh, I need to make it my layer active. Let's correct quickly this. I will select the point, double mouse click on layer, 3D points, and that's it. And go back to the layer, to the point. I also need the highest point. This is probably here, like so. And of course we see the 3D height also here. And then in addition, I need to draw the roof the same way as I did actually for basement. Create new layer, set my color. I love thickness 3 because it's nice visible. And I will also use, let's say, mesh for the drawing the roof. Okay, I could create triangles that later on you can then easily also calculate the 3D area, that they exactly know how much material they actually need to get out of it. I just select, I just draw one triangle. If I select this one, you have also here the 2D area of this triangle, which is available. Okay, cool. This is it. Most of everything. So hopefully you get a really good idea how to combine those images. At the end, we show you also some addition CAD functions to get the real end results. And nevertheless, try it out by yourself. If you'll need some help in addition, feel free to contact us. Thank you for listening and wish you a great day. Bye bye.